Ladies and gentlemen, welcome to my NestJS tutorial. This is going to be an intermediate backend tutorial where we'll start from scratch and build up to a production level backend code base using NestJS. So I recommend having some backend knowledge and TypeScript or at least JavaScript. But don't worry, I'll walk you through everything step by step. We will cover a wide range of topics, with each video building on the previous one, so make sure you follow along. We will start by creating a somewhat real-world application and move on to the advanced topics like configurable modules, circuit breakers, cron jobs, microservices, message queues, design patterns, and more. So this is going to be a long tutorial separated into several videos. By the end of this series, we will have a backend architecture similar to what you'll find in a production level complex application. Lastly, all the code will be available on the GitHub, so if you get stuck or just want to check it out, the link will be in the description. If you have any questions or run into any issues, feel free to email me or comment down below. I'll do my best to help. So without further ado, I hope you enjoy the tutorials and let's get started. Before we dive into NestJS, let's talk about Node.js. Node.js includes almost nothing by default. Developers are in charge of setting up everything, like how you handle routing, API calls, code organization, file structure, and so on. There are plenty of frameworks like Express.js that make some of these simpler, but they all still require a lot of effort and configuration. And NestJS is a framework built around Node.js. It abstracts away many of these setup tasks like TypeScript, API routing, error handling, middleware, etc. It provides an application architecture from the start that allows you to create highly testable, loosely coupled, scalable, and easily maintainable applications. By the way, NestJS is using Express.js under the hood by default and can even be swapped to use Fastify. With NestJS, we can build REST APIs, microservices, pub/subs, cron jobs, and even WebSockets. Okay, I just opened a new window in my text editor, which I'll be using Visual Studio Code for this tutorial. First, let's make sure we have a recent version of Node.js. Let's enter node -- version in the terminal. Make sure you have either the most recent LTS or current version installed. I have version 20. If you don't have Node, I'm going to let you install Node on your own, as long as you have npm installed with it, and you can check it by npm-v to see that. You are good to go from there. And after that, we can install the Nest command line interface, or CLI, by entering npm ig at nestjs/CLI. This might take a minute or so. I have the CLI already installed, so I skip this step. You can pause the video and come back when everything's done. Once it's done, you can make sure Nest is installed correctly by entering nest -- version. If you see a version number come back, you are good to go. The CLI is a tool that helps us generate files, run, and compile our application. Also, there are a lot of more use cases and commands for them. You can check them out by typing nest -- help. You don't have to memorize anything other than this command. Okay, now let's create our Nest application. Let's enter Nest new. And the CLI is going to ask us the name of this project. So we are going to be creating a REST API for an e-commerce-like application. Let's call it Market Server, being the server side of this application. Next, the CLI will ask us what package manager we'd like to use. I'm going to select npm, but if you prefer Yarn, you can go ahead and select it. This might take a while. You can pause the video and come back when everything is done. Once everything finishes, let's change our directory into our application. Let's start our application. Let's enter npm run start. This is going to start up our application, starting an HTTP server, listening on port 3000. I'm going to be using Postman to make HTTP requests to our application. So let's hit HTTP localhost 3000. where we see hello world coming back from our application. Alright, let's break down what's inside an NestJS application. Keeping a clear separation of concern is piece of cake with NestJS. Everything's nicely structured, so you don't need to stress about organization. If you look into the root directory, you'll spot some familiar files like package.json, gitignore, tsconfig files, and sdin configuration. But the real magic happens in the source directory. At the heart of our Nest application sits the main TS file. This is where we kick things off by creating our application with nestfactory.create and specifying an app module. With this, we can listen to port 3000 and bootstrap our app. If you look at the app module, it's like the brain of our app. containing everything necessary to run. This module can also hold smaller modules for specific features, and the app module is just a regular class with an add module decorator on top. If you're not familiar with decorators, think of them as functions that add logic. NestJS loves using decorators to define various things. Inside the add module decorator, NestJS encapsulates all the important stuff for this module's context, and we have a controller and provider here. So let's take a quick look at the app controller. It's just another class, but this time with a different decorator. Controllers handle specific requests in our application, and this controller uses the app service provider to separate business logic from the controller itself. We'll dive deeper into providers and dependency injection later. Now if you look into the app service provider, it's doing a simple job, returning hello world. This is where hello world returned when we hit the localhost 3000 a moment ago. And there you have it. Right now, we have a simple application with just one module, and we'll be adding more complexity as we go along. Nest also comes with an additional script we can use when we are developing, giving us almost instant compilation and automatic server rebuilds on every file change. Just enter in npm run :dev. Now we could see that Nest started our app in watch mode, and it's actively waiting for file changes. Let's change this hello world to hello YouTube. And save. Let's go to Postman and hit the endpoint again. And we see hello YouTube. Okay, let's continue with creating a controller. Controllers are the building blocks that handle requests. We can generate a controller with the Nest CLI by running nest generate controller, or the short form nestg-co. After the CLI asked us for the name of the controller. Since this app called market, let's call our first controller product. As we can see, CLI automatically created a controller and a corresponding test file for us. Also, we can see it updated our app module. Edit this new product controller to the controllers array. And if you don't want to generate a test file, we could simply pass the no spec flag. Like so. Also, files we just created ended up in the directory based off the name we selected, in our case, source/product. If you want to generate something within a specific folder, we can just type in the directory or directories with slashes prior to the controller's name. For example, nestg-co server/controllers/categories. And if you want to just test and see what it will do and where it might place things, we can always use the dry run flag to see the simulated output from the CLI. And it shows where it will have been created the files. Okay, let's go to our product controller. In NestJS, the fundamental building blocks of controllers are classes and decorators. Controllers manage requests in our application. But how does the application determine which URL corresponds to which controller? This is where the controller decorator comes in. You can pass a string to this controller, which provides the necessary metadata for Nest to create a routing map, linking incoming requests to the corresponding controller. We can see that this string product is passed to the decorator, linking /product URL to this controller. In this NestJS common package, we have decorators for all the common HTTP verbs. Let's create a getHTTP handler. First, I'm going to create a method inside the controller and decorate this method with the getDecorator. And import this decorator from NestJS common. And for now, let's add a return statement like all products. With that, we've successfully mapped our first GET request to the /product route. Let's save it and try to access this GET route now. We got all products from the API. Now, if you wanted to have a nested URL for this specific GET request, just as with controllers, all HTTP decorators accept one parameter, a string. This creates a nested path and appends it to the path defined by the controller. If we update our GET request to GET types, we can access this route by /types. Okay, let's say we want to make a GET request to products/1, where 1 is a dynamic ID. To handle this, we can add route parameter tokens to the path. This allows us to capture these dynamic values from the request URL and pass them into the method as parameters. So let's create another endpoint with a method called getProduct. And add the nest getDecorator on top. This time, let's pass $ID to the getDecorator. This indicates that we're expecting a dynamic route parameter named ID. Then use another next decorator at param and name it params. This decorator allows us to retrieve all incoming request parameters and utilize them within the function body of our method. When we don't specify anything inside the param decorator, we receive all request parameters. This allows us to access params.id from the object. So let's try return product with ID params.id found. However, there might be times when we only want to access the specific parameters from the params object. When we need it, we can specify a string inside it. To target a specific part of the params, we'll directly input ID within the decorator. Also, we'll update our param name to ID type of string to align with these adjustments, and then we can use ID directly. So let's switch to Postman and try to access this product/1 route. And we have product with ID 1 found. Perfect. When we change it to 2, it returns 2. Okay. Now let's look at how we can handle post requests and retrieve the request payloads that are typically included with them. Similar to the param decorator, we have another decorator for accessing the request body, known as the body decorator. Let's add a new method called createProduct to handle post requests and decorate it with the post decorator and import it from the NestJS common. And let's use another decorator called body and name it body to test if everything functioning correctly. Let's return the body in our method so we can expect the payload return from the response. Now back to Postman. Let's send a post request, selecting type JSON. Let's say name is bread and price is 5 and send it. And yes, the request body is automatically accessed from the endpoint method. Also, we can pass a string to the body decorator, similar to how we used param to access a specific portion of the body. Let's save it and hit the endpoint again. And we got the name. However, this might lead to potential validation issues since only the specified property will be validated. Okay, next, let's explore how to handle other common operations like update and delete. For updates, we can use two HTTP methods, patch and put. A put operation replaces the entire resource, and the request payload must include the complete object. In contrast, a patch operation allows us to modify only part of a resource, enabling us to update even a single property. Okay, let's add a patch endpoint to our product controller by creating a new method called updateProduct and decorate it with the patch decorator on top. Inside the patch decorator, let's pass in the string $ID to indicate which property we are going to update. Since a patch operation partially updates a single resource, it requires both an ID and a payload with the update values. We need to use both param and body decorators for this. In the method signature, use the param decorator to get the incoming request parameters, passing in ID and naming this parameter ID type string. Our second parameter will be the request body, so we'll get it using the body decorator and call this parameter body by passing both the ID param to indicate which entity to update and the request payload to update that existing resource. We have everything we need. So let's add a simple return statement to this. Now for the delete operation, we'll add a new method called remove product and decorate it with the delete decorator, passing in :id to specify which product to delete. In the parameters of this method, we use the param decorator to grab the ID from the incoming request and lastly, let's add a return statement like that. Now if we switch to Postman, if we do a patch request to the product /1 with 1 being the ID, we should see updated 1. Change our method to delete and push send again, and we should see deleted 1. Okay, everything works. Now let's talk about services. Services are we separate our business logic from our controllers. We are making our business logic reusable in various parts of our application by doing that. And to create a service using CLI, let's enter nest generate service or NestJS in shorthand. Let's enter product for the name, and the CLI will generate a service and a corresponding test file for us. And the CLI automatically includes this service to the providers array of the closest module, and it's being app module for our case. In NestJS, each service is a provider. The main idea of a provider that it can be injected as a dependency. This means objects can create various relationships with each other, and the function of wiring up these objects can largely be delegated to the Nest runtime system. And providers are just a class annotated with a decorator called Injectable. And this service will be responsible for data storage and retrieval and is designed to be used by the product controller, or it can be used anywhere else that the functionalities of this service provides. And to inject a provider, we simply use constructors. Let's define a constructor in the product controller. And Nest will handle dependency injection for us. This is achieved by looking at the type of whatever we pass in the constructor's parameters. Let's start by typing constructor, and let's write private read-only product service. We use the private access modifier here, which allows us to declare and initialize the product service in the same place, also making it accessible only within the class, hence it's private. And the read-only keyword, while more of a best practice, ensures that the service reference isn't modified and is only used for accessing its members, and we name our parameter product service. Managing dependencies is very straightforward in Nest because they are resolved by their type. For instance, we use the column product service here. Nest will resolve the product service by either creating and returning a new instance for our product controller, or in the case of a singleton, returning the existence instance if it has already been requested elsewhere. Generally, services handle business logic as well as interactions with the data source. For now, we are going to work with some mock data, but don't worry, we're going to be working with real databases. For now, let's use this array as our database. And let's create a resource entity for product to define their type. Let's go ahead and create an entities folder inside the product folder. Within the entities folder, let's create another file and let's call it product.entity.ts. Since this is going to represent our resource entity, let's add a few properties to make it look like it's coming from a real database. Let's create and export a class named product and give it a few properties: ID, type number, name, type string, price, type number, and tags, which will make an array of strings. And let's go and update our resource to use this new class. And let's make sure we set the product to type array of product. And let's also add a single entity to this array to create some CRUD operations around it. Let's say ID 1, name, bread, price 5, and tags fresh, whole grain, and baked. And let's add some business logic to our service. And by CRUD, I mean the big four: create, update, read, and delete. I'm going to write some corresponding business logic codes to our controller methods. Let's add get products, and this returns all the products. Let's add get product by ID. This takes an ID parameter and returns the matching product. And let's add create product. This takes a new product DTO. Type any for now. And also let's add update product. That takes an ID and update product DTO. And let's first get this product by ID. And if the product exists, assign the update product DTO to product and return true. And if not, let's return false to demonstrate. What's left? Remove product. That takes an ID. And let's first find the index of this product. Product.id. And if the product index is bigger than 0, let's splice it and return true. Otherwise, return false. Okay, in this code, we have functions to interact with our data sources, allowing us to get products, get product by ID, create product, update product, and remove product. Remember, these are just sample implementations without a real database, but they illustrate the concept. Services are where the core business logic and data interactions should be held. Now return to our product controller and use these new methods. For the getProducts method, let's call getProducts. GetProduct, let's call getProducts by ID, passing ID. For the create product, we'll call the create product and pass in the body. For the update product method, let's call the update product, passing both ID and the body. And for the remove product method, let's call remove product, passing the ID. Now let's save and test if our provider is called from the updated routes. First, we'll make a GET request to the product/1 endpoint, and we get the product. Now let's test the /product endpoint. Expect an array of all product. Then we'll test the delete functionality, passing in one ID and confirm we get true back. And let's get all the products again and confirm the product is deleted, and we got an empty array back. Looks like everything works. Alright, now let's talk about modules. Modules are a fundamental way to organize the components of our application. In most applications, you will end up with multiple modules, each encapsulating a related set of capabilities. This approach helps manage complexity and maintain clear boundaries within the application. For example, if you're implementing a product feature, we'll group related components, such as the product controller and product service, into a single feature module. These components are closely related and should be encapsulated together. So far, our application has everything lumped into one single module. Let's refactor our application by encapsulating the product controller and product service into a separate product module. And to generate a module with the CLI, we can simply run nest g module product. This command will create a module class and automatically add it to the imports array of the nearest module, which in our case, the app module. A module in NestJS is just a class annotated with the module decorator. This decorator provides the metadata that Nest uses to organize the application structure. The add module decorator takes an object with properties that describe the module. Modules have four main components. Controllers are the API routes that the module will initiate, and exports, these are the subset of providers within the module that should be available wherever the module is imported. Then imports, the imports array allows us to list other modules that this module requires. The exported providers of these imported modules become available within this module. And finally, providers list services that need to be instantiated by the Nest injector. These providers are available only within this module unless they are added to the exports array. So let's group our product controller and product service into the new product module. This will help us practice grouping and modularizing our application's functionality. Inside the add module decorator, let's add the controllers property, which expects an array, includes product controller, and next add the providers property, also an array, includes product service. And also, since product controller and product service were originally in the app module, we need to remove those references from the root module to avoid any unexpected issues, as they will be initiated twice otherwise. So let's remove them from here. So as we can see, a feature module organizes code relevant to a specific feature, helping us keep code organized and establishing clear boundaries for our application and its features. This approach helps manage complexity and ensures adherence to solid principles, especially as the application grows. Now let's go to Postman and test our applications again. Alright, looks like everything works. We have successfully encapsulated our product logic into its own dedicated product module. Alright, that's it for now. In the next section, we will make an intro to exception filters and dive into DTOs. So hit sub, hit like, hang out in the comments. That's been it for this one. Thanks for watching. Catch you guys in the next one.